Lesson 137, misleading graphs. So before we get on to circle graphs, we're going to take a minute and look at some ways that graphs can be misleading. And what that means is that these graphs are going to be showing information or showing a certain set of data, but it's going to be in a way that gives you an inaccurate impression of that data. So it's going to have the data on it and it's going to look a certain way. So if you take a quick glance at the graph, you might draw some certain conclusions about that information, but it's actually going to be inaccurate in terms of your conclusions about that data. That'll make more sense once we look at some examples. So let's start with the first one here. Here we have two bar graphs that are showing the exact same information. All right, so we've got the increase in the average house price in 2 different years. However, these graphs look very different. And the reason that they look very different is the scale on the side. All right, so if you compare the scales on the sides of these two graphs, you will notice that for the first graph, maybe let me label them. This is graph number 1, graph number 2. Graph number 1 does not start at 0. Graph number 2 begins at 0. Okay, so graph number 1 doesn't start at 0. And what ends up happening then, if you don't start at 0, is that suddenly it looks like from the year 1998 to 1999, the house price massively increased. Even the title gives an incorrect impression, right? The house price massively increased. It looks like the price of a house tripled in 1 year based on the sizes of those bars. But if you look carefully, you'll notice that in 1998, oops, I need to go back to pen. In 1998, the house price was $80,000. In 1999, the house price was $82,000. That is not a tripling, that's an increase of $2,000. But because the graph doesn't start at 0, and because of the size of the bars then, it really looks like there was a massive or a giant increase in the price of the house. Graph number 2 does a better job of showing an accurate picture of the information. Even though the information is the exact same in both of the graphs, graph number 2 gives you a more accurate, truthful picture because the bars are close together in size, right? You see 1998, 1999, very, very close together. It's showing that there's a little bit of an increase, but definitely not a tripling in the price. So graph number 2 is less misleading than graph number 1. Graph number 1 is very, very misleading. If you were to just take a quick glance at that, you would think, wow, house prices have tripled. That's a giant change. Whereas graph number 2, you look at it and you notice, yep, the house prices have increased, but they haven't increased by as much as the first graph gives you the impression they did. All right, so not starting at 0 with your scale can really change how your graph looks, and sometimes it can give a very inaccurate impression and the graph can be very misleading. The same thing can happen with line graphs. So here we have, once again, two graphs that have the exact same information, the high school dropout rate. Graph number 1 makes it seem like there was a giant decrease in the number of people who dropped out of high school before graduating, right? That line very, very steeply declines. But you'll notice, once again with the scale, graph number 1 does not start at 0, whereas graph number 2 starts at 0. Okay, so showing the same information, but because graph number 1 didn't start at 0 and the intervals are much smaller along that scale, it gives you the impression that there was a sharp decrease in the high school dropout rate. Whereas if you look at graph number 2, you'll notice there is a decrease. That line is going down, but it's not at such a drastic rate, so you can get a more accurate impression of really what's happening there. Here's another example of the profit of a company from October to March. Graph number 1 gives you the impression, because of how sharply this line goes up, that this company is really, really increasing its profits a lot. All right, whereas graph number 2, there is a steady increase, but it's not such a drastic change. Now, if you look at the scales here, you may be tricked because you look and you see, oh, both of the graphs don't start at 0. They've got that broken line and then they jump right up to a 14,000. So you may think, that's kind of strange. But if you look closer, you will notice the reason graph number 1 has that sharp increase. If you go a little bit higher in the scale, you will notice that originally it was going up by $500 at a time. But then suddenly we get to this point in the scale and it starts going up by 100s at a time. So the scale interval changes halfway through, which is what is causing that giant upswing in profits. So this is why making sure that your scale has equal intervals is really, really important. If your scale doesn't have equal intervals, your information is going to be misleading. Your graph is going to show or to give your it's going to give an inaccurate impression. Okay, so graph number 2 does a good job of making sure that the intervals are equal, which is showing the true information that there is an increase in profit, but it's definitely not as drastic as the first graph makes it seem. And even in illustrations that are not exactly graphs, but they are illustrations that have graph-like qualities showing you something, there can be misleading parts. So if you look here, this is an illustration showing the number of houses sold per year, and it's a very, very misleading illustration. Because if we look here, in 1996, 100 houses were sold. If we look over here, 1997, 200 houses were sold. Now, the first house represents 100 houses. The second house represents 200. And for that one, it looks like we've added, another chunk of the house, which looks like it's almost double. So that kind of makes sense as the next illustration. The problem is, back to this slide. The problem is when we get to 1998, the size of the house has not tripled from 1996. So from 1996 to 1998, the house should have tripled because it went from 100 to 300. But the size of the house hasn't tripled. They really just added another window here. All right. And then they used the same size house for 1999. And it looks like even the same size house for the year 2000. All right. So 320 houses and 400 houses are not the same number of houses, so they shouldn't be represented with the same size. So just a lot of things to be aware of when you're looking at graphs in your textbooks or any other places that you might see them in the news, in books, in articles, to really be looking and thinking to yourself, is this an accurate representation of the information? So just a warning to not just take a quick glance at something and think, and to just take your quick impression from it, to really take the time to look at the scale, look at what's happening, to make sure that the graph is not giving you an inaccurate impression. And your exercises today will help you through that. There are going to be a few more misleading graphs for you to look at, and you'll have to figure out why they are misleading. And that's all there is to it. You know the drill. If you have any questions, let me know.